Hello sir, I am Anushka Roy from second year Electronics and Communication Engineering Department. Today, I will be presenting my CA1 presentation for analog communication. My topic is amplitude modulation. Here is the content I will be covering. Introduction to modulation, types of modulation, amplitude modulation, components of AM signal, expression for amplitude modulated wave, advantages and disadvantages, application and conclusion. First, we need to understand what modulation is. Modulation is the process of varying a carrier signal to transmit information. It allows signal to travel long distance without significant loss or interference. Modulation is widely used in communication systems, including radio, television, and mobile networks. So, why is modulation necessary? Enables long distance signal transmission, reduces antenna size requirement, prevents signal interference by shifting frequency bands, improves signal quality and noise resistance, transmit multiple signals simultaneously. There are different types of modulation which are broadly classified into analog modulation and digital modulation. Analog modulation is further divided into two types: continuous wave modulation, pulse modulation. Continuous wave modulation is also divided into three types: amplitude modulation, which we will discuss in details in the following slides. The others are frequency modulation and pulse modulation. On the other hand, digital modulation is also classified into three types: amplitude shift keying, frequency shift keying, and phase shift keying. Now, let's focus on our main topic, amplitude modulation. Amplitude modulation, or AM, is a modulating technology mainly used for radio carrier wave-based message transmission. Amplitude modulation modifies the carrier wave's amplitude in accordance with the message signal, such as an audio signal. There, the mechanism of AM can be a complex interaction between modulating waves and carrier signals in the basis of AM. By means of rigorous modulation procedure, information is encoded for transmission by the carrier wave's amplitude, which experience minute variation in response to the modulating signal. Demodulation techniques use complex circuitry to accurately detect and amplify the modulating waveform. These techniques are crucial for recovering the original signal from AM transmission. In simple terms, AM works by altering the height or magnitude of the carrier wave to match the information we want to send, then changing it back at the other end to hear or see the message. Here are the components of AM signal. Carrier signal, a high frequency sinusoidal wave that acts as a reference. Message signal, the actual information signal. Modulated signal, the combined carrier and message signal after modulation. Then the sidebands, our sidebands known USB. Its frequency is higher than the carrier frequency, containing message information, and lower sidebands known LSB. Its frequency lower than the carrier frequency, containing message information. We can calculate the bandwidth. It's 2 into maximum message frequency. Here the expression for amplitude modulated wave. Carrier wave will be generally a high frequency wave and similar to sine or cosine wave. It can be represented as Ct equal to AC sine omega Ct, or can represent as Ct equal to AC sine 2 pi fct. Here AC is the amplitude of carrier waves, sine omega t is the phase of carrier wave, fc is the frequency of carrier wave, and Ct is our carrier wave. Modulated signal is also analogous to a sine or cosine wave, and it represents as mt equal to am sine omega mt or m sine 2 pi fmt. Here am is the amplitude of modulating wave, sine omega mt is the phase of modulating wave, fc is the frequency of modulating signal, and mt is the one modulating or input signal. Now, superimposing modulating signal into a carrier wave to interpret the data and speech information, and thus also varying the amplitude of the carrier wave in accordance with the amplitude of the modulating signal. Hence, the amplitude modulated wave ST will be AC plus AM sine omega MT sine omega CT. This is the general form of an amplitude modulated wave. There are many advantages, like the cost of amplitude modulation is low. Amplitude modulated signals are reflected by the earth from the ionosphere layer. Its required carrier frequency is low. It requires a simple transmitter and receiver. The demodulation of amplitude modulated signal is less complex due to the use of the circuit having few components. However, there are also some disadvantages. Like amplitude modulated signals are highly susceptible to peripheral noises. Receivers of these signals find it difficult to distinguish between signals and noises. Amplitude modulation is less efficient in terms of bandwidth usage and power usage. The bandwidth of the modulated signal is twice the frequency of the signal wave. Only the power in the sidebands is used. There are the application like broadcasting. AM radio station operates on medium wave and short wave, still widely used in many rural areas due to its long range transmission capabilities. AM is used in military and marine communication, like used for long distance communication, where FM is less effective, preferred in shortwave communication for global reach. Early television transmission. Video signal were transmitted using AM before digital TV took over. It also used in emergency communication system, used in disaster situation when digital communication may fail. To conclude, amplitude modulation has played a crucial role in the history of communication, allowing for the efficient transmission of audio signal over long distance. While newer digital methods and frequency modulation offer advantages in terms of quality and noise resistance, AM remains relevant in certain applications like aviation and emergency broadcasting. Despite its limitation, the simplicity of AM and its long-range capabilities make it an essential part of communication systems worldwide. The future may see AM evolving with modern enhancement, ensuring its place in niche areas where reliability and cost effectiveness are prioritized. Thank you.